Hello friends, in this video I'd like to solve the following problem from the Indonesia National Science Olympiad 2023, problem number 2. We wish to find all functions from the set of real numbers into itself, such that f of x plus y equals floor of x plus f of y for all real numbers x and y. It's a fun problem, not very difficult for my taste. Here are my hints. First, show that f of y is always an integer for every real number y. Remember the following property of floor function. A plus integer is a plus that integer outside of the floor. Then set y to be 0 to find f of x and use it, then changing y to y minus f of 0 and set x to be 0. That should lead you to find f of y explicitly. And finally, don't forget to verify your result in the end. So give this problem a try and I will see you in just a minute. Okay, so you know what, I will call my functional equation asterisk. And first of all, notice that f of x plus y is an integer. How do I know it? Because we have floor on the right hand side. Floor of any number is an integer. And that is true for any real numbers x and y. But if you look closely, y is freely chosen. So that really means that in fact for every y, f of y is an integer. Because, you know, y is freely chosen. So for example, I can put x to be 0 and y to be some number minus f of 0, and I have this. Very well. And now, what I wish to do now? Well, now, after noticing that, asterisk becomes the following. Asterisk becomes the following. f of x plus y equals, and now we know that this number is an integer, so it's just floor of x plus f of y. Very well. Now let's set something. Now let's set y to be 0. What do we have? If y is 0, we now know that f of x equals floor of x plus f of 0, some constant. And now I will use this equality to change f of y. So you know what, I will mark this condition double asterisk, and now double asterisk becomes the following. f of x plus y equals floor of x plus floor of y plus f of 0. And now I wish to set some variables. First, set x to be 0 and change y to y minus f of 0. So instead of y, let's put everywhere y minus f of 0. What do we have now? Well, we have f of 0 plus y minus f of 0 equals floor of 0 plus floor of y minus f of 0 plus f of 0. Let's simplify it. Here we have f of y, and floor of 0 is 0. Now we will use again the fact that f of 0 is necessarily an integer, so it's just floor of y minus f of 0 plus f of 0. And this part really is a constant. It's an integer. So we can call it some constant k, which is an integer. And that means that f of y equals floor of y plus k, where k, which is an integer, is some constant. So now we know pretty much everything about our function. It's time to verify our result. So verification. Verification step, very important. Now we will take left hand side and right hand side of our very first functional equation. So I will expand both sides. Left hand side. Left hand side was f of x plus y. And what is it? Well, now we know that it's floor of x plus k plus y, floor plus k. And now notice that this part is obviously an integer, so it can be written as floor of x plus k plus floor of y plus k again. What about the right hand side? On the right hand side we have floor of x plus f of y. Floor of x plus f of y. So it becomes x plus floor of y plus k. Let's look, plus k close floor. Again, we have a bunch of integers. First of all, this is an integer, so these floors are not necessary. So we have floor of x plus floor of y plus k. Again, this entire business right here, it's again an integer, so it's x plus floor of y plus k. And we see that it's exactly the same. This quantity right here and this, they are exactly the same, which means that our solutions, the solutions of our problem are functions of the form f of x equals floor of x plus k, where k is an integer. Any integer whatsoever. And that closes our problem. Very nice problem, I'd say. Somewhat unusual for floors to be in functional equations, but creative problem. So yes, thank you for watching. I hope that you've learned something new this time, and I will see you in the near future. Goodbye.